NASA's James Webb Space Telescope has barely woken up, and the universe is new. More puzzling, more lovely than mankind's fantasies. And these multitude of little specks are stars. This large number of little dots are universes. Some of which are greater than our own. Letting the cat out of the bag, we might have quite recently found expected proof of intelligent life beyond Earth. This is a gigantic revelation, and we feel that it's a tremendous disclosure. That is the most thrilling part of this telescope, of this striking instrument we put in space. Finding things that we didn't expect that we can't make sense of. Because that means we need to overhaul how we might interpret the universe. Well, JWST is exceptional to such an extent that, assuming you invest sufficient time, you could probably find any galaxy that ever formed in the universe. It's actually that strong. In the domain of science and huge secrets, the subject of what existed before the Titanic effect has ignited serious debates and enamored minds for a long time. This legendary interest doesn't simply challenge how we could disentangle the universe. It pushes the very limits of human knowledge. Imagine standing at the edge of existence, looking into the immense unknown, and contemplating what lay there before our universe appeared. The event of the Big Bang marked the start of history, space, and all that we know. Yet, was there a moment prior to this? Might there at some point have been a condition of nothingness, a calm before the stupendous cosmic event began? And if this is valid, was that nothingness? Or maybe was there something significantly more baffling that existed before time itself? As we dig further into this question, science takes us on a journey beyond the universe's starting point into investigations that challenge our very view of reality. Physicist Brian Cox, famous for his explorations into the marvels of the universe, suggests that something shocking could have existed before the Big Bang. He invites us to reconsider how we might interpret reality and existence. In this investigation, we will break down the science, the theories, and the astounding mysteries that might help us understand what existed before all that we know. We will examine ideas such as cosmic inflation, quantum fluctuations, dark energy, and even multiverses. The answers we uncover may shock you, but they could also provide new perspectives on our position in the universe. Plan to dive deep into a realm beyond imagination, where science meets mystery and the shadows of the unknown leave experts astounded and sometimes perplexed. Let us investigate what existed before the Big Bang and why these speculations challenge all that we assumed we knew. To appreciate what might have existed before the Big Bang, we must first understand what the Big Bang really was. The Big Bang, as scientists describe it, refers to the moment when the universe became extraordinarily hot and dense, expanding rapidly to kickstart the development of all matter, energy, and the fundamental forces. When we gaze toward the night sky, we see evidence of this fiery beginning, with galaxies fanning out from a singular point. But why did this happen, and was there a time before this hot, dense start? According to the theory of cosmic inflation, there was indeed a preceding phase, and it was far from empty or quiet. Inflation suggests that before the Big Bang, the universe was in a state that was cold, empty, and smooth, similar to a giant vacuum. However, this vacuum wasn't truly empty. It contained a massive amount of energy that fueled the rapid expansion of space itself. This expansion, known as inflation, happened so quickly that it effectively set the stage for everything that followed, in a fraction of a second. Space expanded at unbelievable speeds, slowing down only when the energy converted into matter, particles, and the forces we observe today as the Big Bang. But what was the nature of this energy? Why did it suddenly create the universe, and why did it stop? Scientists suggest that this inflationary phase created patches of the universe, with each patch experiencing its own Big Bang. Imagine a fabric growing endlessly, with tiny bubbles forming throughout, each bubble representing a universe, including our own. This idea, known as the inflationary multiverse, proposes that there could be countless Big Bangs and an infinite number of universes. Our own is just one of many. This vast, mind-bending concept challenges how we might interpret the universe and leaves us wondering what else is out there. The notion of nothingness before the Big Bang is speculative, not substantial. Regardless of whether we strip away all energy, particles, and radiation from the universe, it wouldn't really be empty. Our universe is filled with dark matter, dark energy, quantum fields, and other forces that create a complex cosmic structure. Even if we imagine removing these forces and leaving behind a dead space, the universe would still produce new forms of energy. This, in itself, confounds scientists, as it suggests that true nothingness may be impossible within our current understanding of physics. Space itself has properties, rules, and constants that prevent it from being entirely empty. For instance, there's something called zero-point energy, which represents the lowest energy state of quantum fields. In this state, particles can still spontaneously appear and disappear, creating an odd hum of activity even in what should be empty space. This challenges our concept of a true void and suggests that, yes, even before the Big Bang there was something, a mystery. One of the most fascinating theories in modern cosmology is the idea of eternal inflation. If inflation could create our universe, it's possible it could continue forever. Brian Cox describes a vast inflationary multiverse, where universes are perpetually created and continue to expand. Imagine each Big Bang as a spark igniting a new universe, while inflation goes on in other regions, creating countless other universes. This process could, in theory, continue indefinitely. This idea of a fractal universe, where each new universe generates its own Big Bang, leads to a captivating thought. Our universe is just one tiny part of an epic, boundless system that is constantly evolving and creating new universes. What if the unsettling truth is that there is no before or after, but instead a timeless pattern of universes forming and dissolving? How we interpret nothingness changes further when we consider quantum field theory. According to this theory, the universe isn't a collection of matter floating in space. Rather, it is a complex web of energy fields and interactions that fill the universe, interacting and creating everything we observe. Look like unpretentious oceans with particles going about as waves or unsettling influences. In any event, when fields are at their most unimportant energy level, known as the vacuum state, they are still dynamic. Particles can show up and vanish in these fields, rapidly gaining energy before returning it. This peculiarity leads to virtual particles, substances that momentarily exist and then evaporate, leaving just a weak memory of their presence. The possibility of virtual particles challenges the plausibility of a genuine void. Imagine an unfilled universe where all matter, radiation, and energy are taken out. Would you not really have anything? According to quantum field theory, you wouldn't. Even in a vacuum, fields would stay dynamic, sometimes creating transient particles. This steady movement in the field suggests that the universe resists our idea of vacancy. The fields and forces endure, filling the universe with a baffling energy that prevents absolute nothingness. This understanding raises a fascinating question. If fields make particles and particles make matter, could the actual universe have emerged from this nothingness, loaded up with quantum fields? Dark energy, a mysterious force currently driving the accelerated expansion of our universe, adds another layer to this question. Did dark energy exist before the Big Bang? Some theories suggest that the presence of dark energy today is a leftover of an energy field from before the universe's development. The properties of dark energy suggest an immense secret power that might have existed in some form before the Big Bang. Some theories even propose that dark energy, in a much stronger state, might have controlled the inflationary stage, causing rapid growth. The presence of dark energy implies that, regardless of whether our universe were absent any and all matter and radiation, this power would keep shaping spacetime. This leads to a major question. If dark energy existed before the Big Bang, might it have created the conditions that led to the birth of our universe? Might dark energy have been the quiet engineer of inflation or even the true beginning of our universe? As we explore this possibility, we face the idea that dark energy could shape our universe and hold the key to unlocking the mysteries of the multiverse itself. Another theory, cyclic cosmology, offers an alternative to the Big Bang as the ultimate beginning. It suggests that the universe goes through enormous cycles of birth, death, and rebirth. In this model, the Big Bang is not a one-time event, but part of a timeless cycle where universes expand, collapse, and then renew in another cycle. This theory implies there was never a true beginning, but instead a never-ending series of universes arising, developing, and renewing themselves over and over again. Cyclic cosmology raises important questions, even about time itself, suggesting that time may be cyclical rather than linear. If this theory is correct, it could mean that what existed before the Big Bang was simply another form of the universe, one that collapsed only to give rise to our current universe. For scientists, this theory provides a rich answer to the question of extreme beginnings, suggesting that there is no definitive starting point. The universe has always existed in some form, transcending our notions of time and existence. Gravitational waves offer another intriguing concept that could shed light on what existed before the Big Bang. These waves, first detected in 2015, are ripples in spacetime caused by the acceleration of massive objects, such as colliding black holes. Some researchers believe that these waves could have originated in the early stages of the universe, during or even before the Big Bang. If true, this could indicate that something occurred before the Big Bang, an event or disturbance that set the stage for the creation of our universe. The possibility of gravitational waves from before the Big Bang presents the chance to detect remnants from a time before time itself. Through our journey into the unknown, we find ourselves at the very edge of what is possible. The universe, with its complex web of possibilities, continues to expand beyond our comprehension. Was there something before the Big Bang? And if this is true, might it have been? As we continue to push the boundaries of science, we approach a realm where mysteries still reign. What lies beyond our understanding may remain a mystery, or perhaps one day we'll discover that before the Big Bang, the universe was simply one phase in an eternal cycle, a continuous march of creation and destruction, where reality, like dark energy, endures forever. As we delve deeper into these cosmic questions, we find that the lines between known science and speculative hypothesis often blur. One of the most captivating aspects of the universe's beginnings is the role of quantum fluctuations. In the quantum realm, small fluctuations in energy can lead to the creation of particles that seemingly appear out of nowhere. These fluctuations suggest that the fabric of the universe may have sprung from a quantum vacuum, where particles are constantly being created and destroyed. The concept of a quantum vacuum doesn't imply a total absence of existence, but rather a state filled with potential, where energy is constantly in flux. This aligns with the idea that the universe was born from a quantum fluctuation, potentially driven by quantum processes that existed before the Big Bang. These fields may have provided the initial spark for the creation of spacetime itself. In this scenario, the Big Bang can be seen not as a singular catastrophic event, but as the beginning of a new phase in a constantly evolving quantum field. Some theories even suggest that the observable universe we know could be just one of many bubbles or regions within an immense cosmic multiverse. Each bubble could have different physical constants and laws of nature. In this view, the Big Bang may not have been unique to our universe but part of an ongoing process of bubble creation within a larger multiversal system. These bubbles may have formed as quantum fluctuations in the primordial vacuum, with each universe having a different outcome based on slight variations in its initial conditions. Exploring this further, we encounter the possibility that the multiverse may not be completely inaccessible to us. Some cosmologists believe it could be possible to detect evidence of interactions or collisions between our universe and neighboring ones. These traces could be imprinted on the cosmic microwave background radiation or even in gravitational waves, as mentioned earlier. Detecting such evidence would require advancements in observational instruments and technology, but finding signals from other universes challenges our concept of ultimate limits. Moreover, parallel universes open exciting pathways for understanding the nature of reality itself. If multiple universes exist, each with its own set of physical laws, the very definition of reality could extend far beyond our current understanding. It might also provide answers to long-standing mysteries, such as the fine-tuning problem, the question of why the constants of nature are perfectly suited for the existence of life. If a multiverse exists, with countless universes having different properties, it could simply be a matter of chance that our universe supports life. As we grapple with these mind-bending possibilities, the role of dark matter remains another mystery in understanding the true nature of the universe. Dark matter, which makes up a significant portion of the universe's mass, is invisible to our instruments but exerts a gravitational effect on visible matter. Its origins and properties remain largely unknown, but it may be intimately connected to the fundamental forces that shaped the early universe. Some researchers speculate that dark matter could hold the key to understanding the moments after the Big Bang, as well as the very fabric of spacetime itself. Finally, as we push the boundaries of cosmological science, we are not only exploring the past of the universe but its future. The quest to understand the origins of the universe, whether it comes from a quantum fluctuation, a cyclic pattern, or the mysteries of dark energy, may ultimately provide us with a deeper understanding of the nature of existence itself. This journey into the unknown is a testament to human curiosity and the relentless desire to uncover the hidden truths of the universe.